Alright, here we go. This is how we're going to do the cart problems with the vectors. So, this is sheet number 9, this is sheet number 9, and this is 7. Here we go. So, I'm going to, let's say 1, 2, 3. I'm going to add them in that order. I can leave 1 right there, and this is like an example in class of using the cart. I'm going to mark this length here. I'm going to add it on right to there, and I'm trying to go quickly here so we can use our time wisely, keeping the arrow the same direction. Okay, so that force added together is this. Then I'm going to add 3 to it, and 3 is this long. I'll mark some new spots here, and you should be marking it better. I'm trying to save some time here, or else this videos will be really long. So, our overall force, okay, if I was to draw in with a pencil the overall force, 1, 2, 3 added together, it would be this, the overall force. And if you push the cart that way, the cart will end up, the final resting place of the cart will be, draw the cart in like that, final resting place. Okay, let's do this. I'm going to do, let's do 1, 2, 3, 4. Okay, add them together like that. So, I'll add 2 to number 1 like this, and it goes in that direction. I'll do it right to there, right along there. Okay, that's 2. Then I will add 3 to that. And I'll add 3 to that here. 3 goes this way. Okay, like that, and the arrow here. Then I'll add 4, and I'm going to mark 4 like this. 4 is this long, from there to there, and it's in this backward direction. So it's kind of there, and it goes this way. Now, the overall force, the combination of them, if I was drawing a resultant, it would go from here to here. That's the overall resultant force, like we did in class. That would be the R. And drawing in the cart, the final position of the cart, that's the center. The final position of the cart would be there, okay? That would be the final position of the cart right there, okay? Let's do another one. Here we go. Let's do 1, 2, 3, okay? So what I'm going to do is 1 is there. I'll add 2 to it. It's kind of nice. I could start with the 1 like that. 2 goes like this, okay? 2 is like this in this direction here. It goes this way. Then I'll add 3 to it. 3 is here. It's quite long. It goes to there. To there. Okay. It goes to there. Now the overall resultant force would be this. I didn't ask you to draw it. I'm just showing you to help people understand this. That would be a resultant force, meaning the cart, the overall final position of the cart. Maybe I'll do it in red again. The overall position of the cart would be that. That's the final position of the cart for 9. 10. Here we go for 10. There's only 2. 1 and 2. So I'm going to add 2 to number 1 like this. I'll go like this. I'll add it like this. Okay, so we only have 2 forces. This is similar to what we actually did in class with the actual cart. That's number 2. The resultant force overall on the cart, combination of these 2, would be this. Okay, again, this is vital. The arrow going that way is super important because that tells us where the cart will end up. The cart's final resting place will be right there. Okay, 11. I have 4 forces here. I have 4 forces. So let's do 1, 2, 3, 4, and I'm going to add them together like this, and together like this. So I'm going to add 2 is right here. 2 goes this way. I'm going to do 2 right there. 2 in that direction. That's 2. 3 is here. 3 is here. 3 will go downward. So now I'm going like this. That's 3. Okay. That's 3, and then I have to add 4 to it, which is here, here, and then I did 4 here to here. Therefore, I end up here. I started here. Let me do that final. That's where we end up. If I was to draw in the resultant, like we usually have to do, the resultant force, if 4 people were pushing their carts with this directions and this magnitude, this person is pushing hardest, this person is pushing least, okay? This would be the direction of your overall force. The result of all 4 of those forces would be that. Therefore, the cart final resting place would be there. Okay? And we will do 12. This is the last one. Okay. There's more forces here. Let's just do it like this. 1, 2, 3, 4, 5. Okay, same basic idea, and if you number them, I think that really makes a big difference and it really helps. So here we go. To 1, I will add this one, number 2. Mark it there. Again, please, you should be doing more accurately than I am. I am in the instance in the interest, of time. I am sort of making a shortcut here that you should not be making. That should be 3. And it's going to go down into the right. Arrow goes there. That's number 3. If you want to write the numbers on there, I think that really helps. 4 is going to go like this. 4 goes like this. Okay, 4 goes like that. Okay, 4 goes that way. That's 4. And then 5 will be right here. Okay, and it goes that way. 5 right here. Okay, therefore I end right there. If I was to draw in the resultant force of those 5 forces, add them all up, because some of them are acting sort of against each other. These are acting against each other, and part of it kind of cancel out. The overall resultant force would be here to here. Draw the arrow. That arrow going that way is absolutely crucial. We would label it R. Okay? And that this question doesn't ask for that, but that's very good to put in there. And then the final resting place of the cart would be right there. Okay? So that's number 9. I'm Mr. Gaz for all the folks at Gazdoni Productions. Thank you for watching.